So the lesson I'm about to cover is incredibly fundamental to all of our volumes and solids of revolution and all of that stuff, and I really kind of wish I had done it earlier. So if you've been struggling with this stuff, this lesson may actually help. The guiding principle that's going to be behind this lesson, which is about the distance between curves, are these two sentences. First, to find a vertical distance, we always subtract y equals equations, and we get expressions that are in terms of x, or just constants. And similarly, to find horizontal distances, we subtract x equals equations, and we get expressions that are in terms of y, or in terms of constants. Now again, if you've been up to date on everything we've done so far, this should make sense. If you've been struggling, write these two things down and sort of get them memorized, right? When you want a vertical distance, you're working with y equals equations, it's in terms of x. If you want a horizontal distance, you subtract x equals equations, and they're in terms of y. I've got 6 examples coming up in the next 2 slides that I hope are going to sort of clarify this. So let's go take a look. So my first question here says, find an expression for the vertical distance between the function f of x equals x squared and the horizontal line y equals 7 on the interval from 0 to 2. To be honest, the interval from 0 to 2 part isn't really necessary. I'm just letting you know what part of the function I'm looking at. So they're saying take the x squared function and the line y equals 7. So this is y equals x squared. This is y equals 7. And I'm asking you to find the vertical distance between these two functions. And what I hope you recognize is that there is no single distance here. I mean, I just drew one of them here, but I mean, I could just as well have been asking for this distance over here, or this distance over here. It's different. And very specifically, if I say it's different depending on what x is. Depending on what x is, the distance between y equals 7 and y equals x squared will vary. And so the way that we get an expression for this distance is by simply taking, and you've heard me say this before, taking the top function and subtracting the bottom function. So the vertical distance between these functions, I'm supposed to have y equals functions. That's great. I have y equals x squared and y equals 7. The distance between these things is 7 minus x squared. If I wanted to, I could plug in different values of x here. For instance, when x is 1, the distance between them is 6, 7 minus 1. When x is 2, the distance between them is 7 minus 4, which is 3. Right? So, and that's it. This is the distance between those two functions. But we've got another one up here. Next, find an expression for the vertical distance between the function f of x equals x squared and the horizontal line y equals 3, again on the interval from 0 to 2. So again, I'll take my x squared function, here it is. I want the distance between that and the horizontal line y equals negative 3. Okay, here we go. Again, this function is y equals x squared. This function here is y equals negative 3. And I want the vertical distance between them. So any one of these distances. In all cases, I'm looking for a vertical distance. I want my functions to be in terms of y. They're already in terms of y. So now I just do the top function, which is x. Oops. I hate it when that happens. We had a graph that was like this. We had the line y equals negative 3. And we were looking for these green distances between here and here. Alright. It's the top function, which is x squared, minus the bottom function, which is negative 3. So our distance between these things is x squared plus 3. Okay. Let's go on and look at the last one. That disappeared, but it'll reappear. There we go. Find an expression for the vertical distance between f of x equals sine x and g of x equals x minus 3. So I'm making it slightly more interesting here. Sine x looks like this. Alright. And x minus 3 looks roughly like this. So we've got some sense of what this looks like. This diagram isn't perfectly to scale, but that's okay. The whole idea is if I want a vertical distance, I'm supposed to subtract functions that are in terms of y. I'm sorry, that are y equals. Notice this function is y equals sine x. This function is y equals x minus 3. Because those things are both y equals, I can find the vertical distance between these things by simply doing the top function, which is in terms of x, sine x, minus the bottom function, which notice is already in terms of x minus 3. And this is the distance between those two functions, right? This is useful if I want to do a revolution. This is useful if I want to do anything where I need to know the distance between functions. So these were all vertical distances. All of my other examples are horizontal distances. So let's look at those next. So now I want to find an expression for the horizontal distance between the function f of x equals x squared and the vertical line x equals 5. So f of x equals x squared again looks like this. And the vertical line x equals 5, I've got this vertical line over here, x equals 5. Notice that even the setup of the problem, it doesn't even make sense for me to talk about a vertical distance. Like I can't find a vertical distance between this and a vertical line. The only thing I could possibly find are these horizontal distances, right? And again, the interval here doesn't matter too much, but note, now that I'm looking at these distances are different, and they depend on what y is. They no longer depend on what x is, they depend, depending on how high up I'm looking, I'm going to have different distances here. And so the interval I'm working with here are y values. The thing I said in the beginning of the video was if you're looking for a horizontal distance, you need to subtract x equals equations, and your answer will be in terms of y. So one of the snags here is I have one equation in terms of x, but my other one is not in terms of x. I have y equals x squared. If I'm going to find the distance between these two things, this needs to be in terms of y. It needs to be an x equals equation like this one is. So easy enough, I'll just square root both sides and get x equals the square root of y. So now the distance between these two curves, usually I do top minus bottom. But in these cases, I'm going to do right minus left. Right. So in this case, our right function is 5 minus the left function is, well, it used to be x squared, but I want it in terms of y, so it'll be the square root of y. That is the horizontal distance between those two curves. Let's look at the next one. I want us to find, again, an expression for the horizontal distance between the function f of x equals x squared. That's this guy. And the vertical line, just notice this should be the vertical line x equals negative 2. Okay, so x equals negative 2. That's back here. Okay. Okay, so I want to find the distance between these things. So again, what I'm looking for is I'm looking for these distances here. To make this now less confusing, I shouldn't have had that. I shouldn't have had this part of this curve in here. If I can take that out, that would be great. Let's see here. Whoops. So there we go. If I'm trying to find those distances, same deal. I need x equals equations. So I'm going to take this thing here, which is currently y equals x squared. I'm going to change it into x equals the square root of y. And now when I'm finding these distances, I want to take my right function, which is now the square root of y, and subtract my left function, which is negative 2. So I end up with the square root of y plus 2. That's my expression. Last example. I want to find an expression for the horizontal distance between the function x cubed. Okay, so the function x cubed. Let's see here. X cubed. X cubed is going to look like this. x squared minus 3. I'm going to throw out this range here. That wasn't what I was looking for. X squared minus 3. X squared minus 3 is going to look like this. And I'm only going to draw on half of that for some strange reasons. Don't worry about it. The problems that we're going to get to in the coming days are going to be a lot, will be more specific than these. These are supposed to just kind of be random examples. If I want the horizontal distance between these two functions, in other words, I'm looking for this distance here. Any one of these distances, they all depend on what what y is. I need to, as I said before, do the right function minus the left function. My right function is this one, which is my square root graph, but I need that to be in terms of, I need that to be an x equals equation. So I'm going to shift this around a little bit. I'm going to make this y plus 3 equals x squared. So x is the square root of y plus 3. That's my right equation. My left equation was previously y equals x cubed. I'm changing that into x equals the cube root of y. And finally, I'm done with this one. My right function is the square root of y plus 3. My left function is the cube root of y. This video is a lot longer than I wanted it to be. What I really wanted to get to is just this idea that when you want horizontal distances, you need to make your functions x equals, they need to be in terms of y, and then you just subtract them. Hope that all made sense. It's really critical for our next video, our next part of the lesson, which I'm really going to try and make shorter now that I'm already long on this one. So I'll see you there.